Hey everybody, Mr. Field back again with another video. You can't get rid of me, can you? All right, guys and girls. So today we're going to be talking about solving right triangles, right? So basically, what this means is we've been doing this a little bit already, but now we have all these different strategies, all these different ways that we can solve for the missing sides and angles in a right triangle. I mean, we have Pythagorean theorem, we have special right triangles like 45, 45, 90. We have the 30, 60, 90 special right triangles. We have triangle sum theorem and so on and so forth. So, and finally now trig, SOHCAHTOA. So we're going to be trying to combine all of these skills and use that everything that we know in order to solve the missing side lengths and missing angles in a right triangle. Before we jump into that, I just want to make sure we jump into some basics. So first and foremost, right up top, you can see that there's all the different options, all the different paths we can take in order to solve for missing sides and angles in a right triangle. So we have finding missing sides using trigonometry. So for instance, if we look at this first example, we're given the angle of 38 degrees. It looks like we're looking for side x. Again, we label opposite, adjacent, hypotenuse because we know that there's a relationship between the three sides in right triangles. You can either use Pythagorean theorem, or in this case, we can't use Pythagorean theorem because we only have one of the side lengths. You have to have at least two of the three in order to be able to use Pythagorean theorem. So we're kind of forced to use trig because this is not a special right triangle. It's not a 45, 45, 90 or a 30, 60, 90. So we're kind of pigeonholed here. We have to use trig in some capacity. So again, label the sides, opposite, adjacent, hypotenuse. Looks like we're missing the opposite side. So we have to include O and A. It's the only other side that we know. So in this case, TOA, tangent. The tangent of 38 degrees is equal to something over 17. And of course, before we can plug this in our handy dandy calculator, we got to get x by itself, which is what I'm demonstrating here by multiplying both sides by 17. And then of course, x is all by itself. We type this in our calculator. Looks like the tangent of 38 ends up being just a decimal, right? 0.781 times that by 17, and boom, we're done. We have this missing side length of 13.3. So sometimes you're using trig to solve for a missing side. Sometimes you're using trig to solve for a missing angle. But again, remember my favorite phrase in this section, the calculator is only as smart as the user. Again, don't forget, make sure, check the mode. Make sure that degree is highlighted like mine is, or you might have problems. In fact, you will. You'll get some really funky, typically negative and decimal answers that just don't make sense in the context of the problem if it's in the wrong mode. So just make sure you have that ready to rock and roll. But again, in this problem, right, we're given theta. We are given two of the three sides in the right triangle, right? However, that's not going to help us solve a missing angle, right? We could use Pythagorean theorem to solve for the opposite side, but that's not what this problem cares about. It cares about the missing angle. So in this case, just remember, we have to use inverse sign. We have to tell the calculator that, hey, when I type in, for instance, like the cosine of, in this problem, looks like 7 divided by 8, that's not 7 divided by 8 degrees. That's the relationship between the adjacent side and the hypotenuse, right? The two sides. So we have to tell the calculator. Obviously, we type in like that. That doesn't really make sense for an angle. Less than 1 degree? Probably not. So that's a big clue that don't forget. You have to hit second and then cosine. Telling the calculator, hey, I'm plugging in the relationship between the two sides. I'm plugging in the ratio. Can you please work backwards to spit out the angle? And in this case, you get about 29 degrees almost. So that's finding missing angles. Of course, we have the good old Pythagorean theorem, like I mentioned earlier. You have to know at least two of the three sides to be able to solve for the third. Remember, we got A, B, and C, where H is C, or hypotenuse is H. That's always the side across from the right angle. So make sure you don't mix that up. A and B are interchangeable. And finally, the triangle sum theorem. We know every triangle, all three angles have to add up to 180 degrees. So we're going to use all of our resources, all of these skills, in order to make sure that we can solve for whatever happens to be missing in these right triangles. That being said, all right, before we get into anything else, I just want to talk about some background information before we solve our two example problems. Just notice that when we're talking about, for instance, triangle ABC, when you see capital letters, for instance, capital A, right, what that's trying to indicate is that is angle A. And then you'll notice across from angle A is side A. Notice they're using a lowercase letter. So like little a is across from big A. You'll notice if I change my highlighter color here, that little b is across from big B. They're across from each other. And finally, last but not least, we have C and little c, right? So the larger, the capital letters are the angles, and the lowercase letters are just representing the lengths of the sides. So I want to make sure we have that, and that's generally how this section is going to go. So that being said, let's talk about our examples. On example one, looks like we have two known angles and one known side. So first and foremost, it's always important just in general to make sure you're using what's given to you to solve. I realized that we could find angle B here, right? We could use the triangle sum theorem. We have 90 plus 64, which is 154. We subtract that from 180. Well, 6 gets you to 60, so I'm thinking this is 26 degrees, if I'm not mistaken. My quick mental math. Now, of course, you know that's true, right? But it doesn't ask for that in this problem. But my point here is when you're choosing a theta, right? First and foremost, you never use the 90-degree angle as your theta, as your reference angle. You're always going to use one of the other two. On top of that, I wouldn't use 26 in general just because it's an unknown. It wasn't originally given to us in the problem. So if you made a calculation mistake, like if my mental math was off and I wrote like 26 when it's really 27, then the whole rest of your problem is going to be wrong. So I would use whatever they give you. That's my general idea. So step one, let's just identify theta. I'm going to use 64 as my reference angle, the one I'm referring to. From there, I'm going to label the sides. Looks like we have opposite. Adjacent would be little b, side B, and side C, the hypotenuse. And we're going to use this information. We're going to use triangle sum theorem or any of the other skills, trig, special right triangles, in order to solve for the missing sides. Well, I know I can eliminate special right triangles because, well, it's not a special right triangle. It's not a 30, 60, 90 exactly, or a 45, 45, 90. So that's not going to be an option using those special right triangle relationships. Pythagorean theorem, can I use that in this case? Not yet, because I only know that this side is 24. Looks like, I think that's feet. That's what it's trying to indicate. But I don't see any other sides, so we can't do Pythagorean theorem. So by process of elimination, we really got to use trig here. Now, I know it's kind of a silly question. It says find angle A. Well, guess what? It's 64 degrees. It's kind of silly. So first it wants us to find side B. So we have to use the information we're given in trigonometry to solve for side B. So I'm thinking we have to use 24 in some capacity. So we have the opposite side, and we're looking for the adjacent side in this first part. So opposite over adjacent, right, should be tangent. So I'm thinking the tangent of our theta, 64 degrees, based on our reference angle, right, is going to be equal to 24 over little b, which is what we're looking for. All right. Now, before we can type this in our handy calculator, we got to get b by itself. So my first move is going to be to get b out of this fraction. The opposite of dividing by b is multiplying by b. Whatever I do to one side, I better do to the other. So running out of the room here, we get b times the tangent of 64 degrees equals 24. Now, I know it's strange that we have this word, right? But the tangent of 64, if you type that in your calculator, it's really just a number. So the tangent of 64 ends up being 2.05-ish. So it's just a number, right? So if I had b times 2, well, how do we solve that equation? How do we get b by itself? We do the opposite. We divide by 2. Whatever we do to one side or the other. So basically, we can do the same moves with this tangent relationship here, these trigonometric ratios. So the opposite of multiplying by tangent of 64 is dividing. Whatever I do to one side, do the other. And anything divided by itself is 1. So we get b equals whatever 24 divided by the tangent of 64 degrees is. So I just got to type that in my calculator. I'm just going to literally say 24 divided by tangent of 64, and looks like we have 11.7. So it looks like B is 11.7 long. So if I make some room, we get 11.7. Now another thing, let's just check and make sure it didn't tell us to round any specific way. I don't see anything, so maybe it says round to the nearest whole number, round to the 10th, 100th place. If it does something like that, make sure you answer the question like that. All right, and then here's the neat part. Now that we know side B is 11.7, we got options, baby. We could do trig again. That's totally an option. One sec. I had a visitor. Anyway, so back to this. We have options, right? We could use trig again. So let's say we wanted to use trig using theta as our 64-degree reference angle. We could then use, for instance, if we wanted to solve for hypotenuse, we could say opposite over hypotenuse, which is sine. I could say the sine of 64 degrees is equal to the opposite side, which is 24 over the hypotenuse, which is c. Get c by itself, plug it in our calculator, etc. I could use a different trig function too. We now know that this side is 11.7, so I could use adjacent over hypotenuse, which is going to be cosine. I could say the cosine of 64 degrees is equal to adjacent side, which is 11.7 over c. However, I wouldn't recommend doing that Again, my caution there is because since you solved for it, if you got it wrong, it's going to make the next part wrong too. So I would go back to the original and say probably sine is your safest bet. By the way, quick shortcut, just throw it out there if you haven't noticed yet. When I'm solving for c, I'm going to multiply both sides by c and then end up dividing by sine of 64. So I realized these are just going to switch places. The shortcut here is we know c is going to be equal to 24, whatever's on top, divided by the sine of 64. I know that's going to happen. So just throwing it out there. It's a really useful skill. Let me just pull up my calculator and we'll see what we get. So we got 24 divided by the sine of 64, close parentheses, pretty important. Bang, 26.7 looks like to be our answer here. Oh, guess I need a pen. Now, throwing it out there, we can quickly do the little discount double check here. Our answer better be bigger than 24. Why? Because this is the hypotenuse, so it better be the longest side. Keep in mind, though, we use trig to get 26.7. You can also use Pythagorean theorem, right? Now that we solved, right, we have two sides. I could say 24 squared plus 11.7 squared equals c squared. We can absolutely do that. And using our calculator to do this quickly, we're going to do 24 times 24, which is 576. 11.7 times 11.7. So we have plus 576, right? And then we would take the square root of that. So the square root of 712.89 better be 26.7. There it is. So no matter how you slice it, we got plenty of options for solving for the missing sides and angles. All right, let's try one more example. So in this case, we only have one angle, right? Or do we? This is interesting. We have, oh, well, technically we do, sorry. So we have the right angle and that's it. And we have two known sides. So in this case, we got to make sure we solve for one of the missing angles right off the bat. I'm going to solve for A. So I'm going to choose A to be my reference angle. You can solve for B. It really doesn't matter. But what I'm getting at is we're going to have to pick a trig function, or we're going to have to use the inverse function, or second sine, second cosine, second tangent, in order to tell the calculator, hey, I'm looking for the missing angle here. So based on my reference angle of A, I'm going to call this side opposite, hypotenuse, adjacent. So looks like we have information for the adjacent and hypotenuse side. So we're going to have to use cosine. You know, the cosine of angle A, or theta in this case, is going to be equal to 30, the adjacent side, divided by 42. Again, the calculator is only as smart as the user. We got to make sure we tell the calculator, hey buddy, I need inverse sine, right? So of 30 divided by 42. That's telling the calculator this, what we're plugging in, is the relationship between the two sides. I need the actual angle. Use your words, field. Here we go. So I'm going to say second cosine of 30 divided by 42. And looks like we get 44.41 degrees. Now, it doesn't say, you know, to use certain rounding rules in this. So if it did, you got to make sure we're careful here. We're going to leave it as exact. I don't think I'm going to torture you and do degrees, minutes, seconds, so you're welcome. But for now, we're just going to call it 44.41. Now, solving for the missing angle B, you could do it the hard way, right? We could absolutely, you know, call this theta, relabel the triangle opposite adjacent hypotenuse, because again, that would change things. Once you change the reference angle, for instance, this would now be the opposite side. This would now be the adjacent side. So we're not going to do all that. We're not going to do all that. We're just going to realize we can use triangle sum theorem. We know every triangle adds up to 180 degrees. So if we just subtract whatever 90 plus 44.41 is, so I'm thinking 134.41, that should tell us what angle B is.